First question, find the value of sine of 2 pi by 7 plus sine of 4 pi by 7 plus sine of 8 pi by 7. Second, sine 1 degree, sine 3 degrees, sine 5 degrees, and so on, sine 89 degrees. Third, cot square pi by 9 plus cot square 2 pi by 9 plus cot square 4 pi by 9 equal to what? Fourth, if root 2 cos A equal to cos B plus cos cube B and root 2 sin A equal to sin B minus sin cube B, then find the value of sin of A minus B. Fifth, find the value of tan of 3 pi by 11 plus 4 sin 2 pi by 11 whole square. Sixth, find the value of tan square pi by 16 plus tan square 2 pi by 16 plus tan square 3 pi by 16 and so on plus tan square 7 pi by 16. So the first problem is, one method is take the given expression as x, sine 2 pi by 7, sine 4 pi by 7, sine 8 pi by 7 as x. Use the same angles with the cos function as y equal to cos 2 pi by 7, cos 4 pi by 7, cos 8 pi by 7. So square it and add, then you'll get 3 plus 2 into cos 2 pi by 7 plus cos 4 pi by 7 plus cos 6 pi by 7. Now here the angles are in arithmetic progression. So you have a formula for series expansion, sum of n terms with the cos functions. So this is same as y. So y equal to sine of 3 pi by 7 upon sine pi by 7 into cos of first angle plus last angle by 2, that is 4 pi by 7. And this you can simplify, then you'll get minus 1 by 2. So substitute back y value, then you'll get x square equals 7 by 4, so x equals root 7 by 2. Second method is square it directly this expression. So sine square theta I can write as 1 minus cos 2 theta by 2 and 2 sin A sin B term. You apply transformations and simplify. Then again here you are getting cos 2 pi by 7 plus cos 4 pi by 7 plus cos 6 by 7, whose value is minus 1 by 2. So the value becomes 7 by 4. So implies x equal to root 7 by 2. In the second problem, so multiply and divide with sine terms with even angles. That is sine 1 degree, sine 2 degrees, sine 3 degrees, sine 4 degrees, and so on, sine 89, sine 89 degrees upon sine 2 degrees, sine 4 degrees, and so on, sine 89, 88 degrees. Now group the first and the last, and second and last but one, and so on. Now, sine 1, sine 89. Sine 89, using the complementary angle, sine 89 is same as cos 1 degree, and sine 1 degree into cos 1 degree is half of sine 2 degrees. In the same manner, all the groups can be done in terms of sine function. So it will get cancelled. So remaining will be 1 by 2 to the power of 44 into 1 by root 2. So 2 to the power of minus 89 by 2. So for the third problem, cos square pi by 9 plus cos square 2 pi by 9 plus cos square 4 pi by 9 we need to calculate. So instead of cos square functions, because we can have a relation between cosecant and cot. So let us consider cosecant square pi by 9 plus cosecant square 2 pi by 9 plus cosecant square 4 pi by 9. So convert into reciprocal sine square theta. Sine square theta can write as 1 minus cos 2 theta by 2. Now, so simplify the numerator and denominator. So numerator, when you take LCM, so the numerator will become 2 into this, and this you can regroup it as 2 times of 3 minus 2 into cos 2 pi by 9 plus cos 4 pi by 9 plus cos 8 pi by 9 plus half of, when you apply transformation, you get this term. Now let us consider only cos 2 pi by 9 plus cos 4 pi by 9 plus cos 8 pi by 9 separately, adding and subtracting 6 pi by 9, cos 6 pi by 9. So this turns out as 0. So the numerator becomes the value 9 by 2. Now the denominator is 1 minus cos 2 pi by 9, 1 minus cos 4 pi by 9, 1 minus cos 8 pi by 9. So that if you expand and simplify, the value will become 3 by 8. So cosecant square pi by 9 plus cosecant square 2 pi by 9 plus cosecant square 4 pi by 9 equal to 12. So cos square pi by 9 plus cos square 2 pi by 9 plus cos square 4 pi by 9 becomes 9. Now the fourth problem, root 2 cos A equal to cos B plus cos cube B and root 2 sin A equal to sin B minus sin cube B. Then find the value of sin of A minus B. The possible values plus or minus 1 by 3 will get. Now, so here you square it and add, you will get one condition. After that, to get sin of A minus B, so you multiply first equation with cos B and second with the equation with Now, first equation with the sine B and second equation with the cos B, and then subtract. Then you'll get the term of sine of A minus B. After that, you simplify. So in the fourth problem, so the first equation we are multiplying with the sine B, and second equation we are multiplying with the cos B, and then when you add, then you will get root 2 sine of A minus B equal to minus sine B cos B. So sine of A minus B equal minus sine to B upon 2 root 2. So we need to calculate sine to B. Now square it and add directly. Then you can get a quadratic in cos to B. So cos to B equal to 1 by 3. From that you can get sine to B. So the value of sine of A minus B will be plus or minus 1 by 3. Next. So the fifth problem is take the inside as sum x equal to tan 3 pi by 11 plus 4 sine 2 pi by 11, convert into sine and cos, and cross multiply and square it and simplify. Then you can get the value as 11. Next, sixth problem. You group the first and last and convert into sine and cos and simplify. So the value will be 35. Next, seventh. X cos alpha plus y sin alpha equal to A. X cos beta plus y sin beta equal to A. And 2 sin alpha by 2 sin beta by 2 equal to 1. Then find the value of A into A minus X upon y square. 8-1. In triangle ABC, cot A plus cot B plus cot C equal to cot theta. Then find the value of sin of A minus theta, sin of B minus theta, sin of C minus theta upon sin cube theta. So seventh one you will get as 1 upon 4. And eighth one you will get as 1.